So next speaker, Professor Rajit Gadh, is professor of mechanical engineering here at UCLA. He's the founder and director of the Smart Grid Energy Research Center, or SMERC. He has a program called UCLA Wind Smart EV Research Platform, which allows the aggregation of EVs plugged into the smart grid. The aggregated system optimizes charging and discharging based on user preferences, grid conditions, and local conditions. There are about half a dozen EVs plugged into UCLA's grid for charging. This research infrastructure is currently being expanded for testing in the Southern California region. Rajit, thank you.
Thank you very much, Shahin. And I think GR's presentation leads into my presentation in a very natural way. GR talked about some of the constraints and so on and so forth, and needs and requirements when you're dealing with situations like apartment buildings. I'm going to talk more about the technology that is being developed by my lab and the infrastructure that we're trying to develop here regionally so we can test some of the ideas, such as the ones that, for example, GR talked about today. So before I start into my presentation, I'll just give a high-level overview of the center that I run. It's called the UCLA Smart Grid Energy Research Center. The major sponsors are Department of Energy, and we have a joint grant with the Los Angeles Department of Water and Power, USC and JPL Caltech. That's a $60 million project funded by DOE. It's a regional demonstration grant, and EV integration into the grid is one of the key areas that UCLA is participating on this particular project. The other activity that we are participating on is demand response. The second grant we have is with the Korea Institute for Energy Research, and that's a rather large 10-year grant, and we just finished the first year on that. And we have another DOE-funded project with EPRI. They are a nonprofit in the electric power sector, and then we have an industry partners program, which we have about 19 companies that participate in the various different research activities and lend us the equipment and expertise. The center hosts thought leadership forums. The next one is on October 23rd. We have something called the Smart Grid Living Lab, and the idea here was to use UCLA's buildings, offices, dorm rooms, parking lots as an infrastructure in which we can install some of the technologies that are coming out not only in our labs but also from local startups, bigger companies, and so on and so forth, and to create that test bed right here on campus. And I'll talk a little bit about the test bed, and Shahin referred to that in the beginning. And of course, we do educational programs and we publish research papers. Overall, in terms of research topics, we have created a wireless information infrastructure on UCLA called the Wind Smart Grid platform for creating smart buildings and smart campus. It's the highway on which you can send data. You can get sensor data from electric vehicle into a control center in the lab. You can get information about exactly how much charge your car has on your cell phone. You can turn off your car charging through your cell phone based on prices on the grid and things of that nature. The second project is demand response, in which the utility can send signals during a hot summer's afternoon to turn off an EV, or perhaps ask the EV to return power back to the grid. So that's called vehicle to grid, and we are also experimenting with that notion in our lab. And then, of course, the EV to grid work, and then we have something called a microgrid, where we bring in solar into EVs and into battery systems and see if you can do complete islanding from a grid. Can you take a building and island it from the grid for a short while? Now, UCLA is a very interesting infrastructure. We roughly do 50 megawatts of consumption, 50 to 70, and then we purchase about 1/3 to 1/4 of that from LADWP. So we're a very interesting facility where we can try out many of these concepts, including the last one, which is cybersecurity on the grid. You can see this is a sort of a picture of UCLA. There's a UCLA electrical power gateway, and then you have the campus, and then you have EVs plugged in, and you have solar plugged in. Well, in the traditional grid model, power flow, communication flow, and control flow were one way from left to right. In the new model, all of these will flow in any which way possible. So think of it that we're going from a situation where IBM would have 4 computers in the whole world, and we'd all use that, to now the computing is sitting right in our palms on a cell phone. So we might have more computing today on a cell phone than perhaps IBM supercomputers 30 years ago. The utility, one of the utility is a very important activity in the research I do. And so one of the things that happens is that if a utility wants to, let's say, control electric vehicles, they have to go through some entity. So we have developed a gateway. And GR talked about a gateway. So we have our own gateway. It's made of all standard communication, standard hardware, but the algorithms and the software has been developed and is being developed, I should say, by our students. And we are releasing the first version of this gateway in the September timeframe. And what it would do is, in a home or an apartment building, for example, it would talk to the appliances. So we have the interface in our lab. If anybody is interested, we can talk about that, to get signal from this gateway into an electric vehicle or into a refrigerator, a washer, dryer, air conditioning system, whatever have you. In the UCLA microgrid that we are creating, the test bed, we're basically putting solar, we're putting batteries. So we're adding EV. So you can see this is about an EV grid here, but you also need to have batteries. For example, what if you have cheap energy at night and you want to store that, or when the wind blows at night, you want to store that at night, and you can then buy wind power in the day from UCLA's grid into your car. So those are some of the technical ideas. But which of them will pan out? Policy folks and economics folks like GR can tell us this is going to work, this is not going to work, but we are creating the infrastructure so to try out all of these concepts. In the EV to grid work, as Shahin mentioned, we're interested in what the consumer is thinking, the EV owner, the driver. So that's very important. That's at the center. And then the utility. The utility will offer these pricing models and so on and so forth. They'll offer programs, incentives to the consumer to charge the car at night, for example. So that's the second piece of the puzzle in terms of our research approach and our research algorithms. And the third is the garage operator. This is very critical. Everybody forgets about the garage operator, but they're like the gatekeeper. And if they don't install the charging stations, nothing's going to happen. So you have to take all of these, put them together, and come up with an optimization that essentially helps all of the above and provides some reasonable compromise for all of the other. And that's our philosophy. Here you see an EV driver plugging into our system, and you basically open your cell phone and you enter your preferences. Say, well, I'm going to leave at 5 p.m. or please charge me when the energy price is less than 14 cents per kilowatt hour, things of that nature. And that data gets inputted into our control center. And then we have, I've just shown a little picture of the control center there, and that tells there's a command center that tells the person in the control center what's going on in their whole grid. So in my case, that's actually sitting in the lab. It's monitoring. We have 7 EVs plugged into my grid right now. So we monitor what's going on with those 7 EVs. And then there's this EVSE, which is the important thing that the garage owner has to actually install. So you can see there are 3 critical sort of constituents of this system. There are a lot of research issues, and I think JR touched on many of those issues. And I think that, my idea is, that at a technical level, there's a communication issue, there's a language issue, there is algorithms, there's the, what sort of, how do you determine whom to charge? 7 people are plugged in, you have only enough juice to charge 3 people. How are you going to determine? Well, maybe one person has said, only charge me when the price is less than such and such, and if the price is higher, well, guess what? Then you give it to the person who's willing to pay more. So of course there'll be some free market type of stuff. Then there'll be maybe some social approach. So we are implementing, and we've implemented an algorithm. And I saw David Chatto. Is David still around? There. He's participating in our round robin social algorithm in which everybody gets an hour. I'm part of that algorithm too. And so David is really smart. He comes in at 6 or 6:30 in the morning, because most people come in at 8:30 or 9. So he circumvents the round robin. But that's important. He gets all the juice for 2 or 3 hours, so that, because at the end of the day, the total resources will be limited. You're not going to have infinite resource. So what you do is you take whatever resource you have, and then you create methods so you can parcel the resources into the different EVs based on the consumer preference and based on other inputs such that the garage operator can give you. So there is user participation, there is price-based control. We are working on system control. We are working on aggregated services. Idea is that suppose you had 100 EVs in UCLA, and let's say each EV was doing roughly 5 kilowatts. Well, that is 500 kilowatts of addressable power. If the utility on a hot summer's afternoon says, can UCLA cut off 1% of the consumption, well, all you need to do is turn off all the EVs, and you're getting your roughly 1%. So aggregation is a big area of research for me as part of my program. G2V refers to charging the vehicle. V2G refers to sending the power back. So if I could take 500 kilowatts and turn it off, well, if the vehicles could get power back to the grid, I can add another 500 kilowatts sending back to the grid. I now have an addressable energy source of 1 megawatt. Now that is nice. That's 2% of the load. So vehicle to grid can be a very interesting idea, and we're exploring opportunities for the utility operators that can incentivize and throw some money into the pocket of the consumer and the garage owner to return power back to the grid when they actually need it during a hot summer's afternoon, and so that they can perhaps charge at night. So that's something going on in my lab, and there's a battery unit in the lab. If anybody's interested, we can talk about that later. Mobile user interfaces are very critical for the user, and we have decided that's the way to communicate with the user. They're used to the mobile phone. This just shows you some of the pictures from the aggregation idea. So you have a bunch of EVs. The utility, for example, one example of the aggregation, a utility gives you how much power you can consume today in an economical fashion. So they give that on a 24-hour cycle, and you can convert that into charging of different EVs, and possibly in the future, even discharging EVs. Today, we're not discharging an EV. Trust me, David can attest to that. I'm not taking power out of EVs. I would love to, though. But this is a battery unit, test unit in our lab in which we are taking power out of this battery unit. Now, luckily, nobody drives it, otherwise they'd get mad. But we are taking, so at a technical level, at some level, at an individual level, it is doable. I mean, we can still do a lot in terms of discharging. We're still not there yet, but that's in the lab. This shows you the parking lot. So you see up there, we have some Chevy Volt and a Nissan Leaf parked up there. And we hope to, add that, add BMW and the Tesla and other vehicles to this fleet. But we have, as I mentioned, 7 cars. And so if you look at our device, our end device looks something like this. It's just a simple box. And all it does is it measures the power consumption. It measures the frequency of the consumption. It measures the phase angle. It measures all sorts of variables. And it feeds that back to the server. And the server is getting information from the utilities. If the utility says, well, right now, I need to do some frequency regulation, can you do that? So our software will say, yes, we can, and this is what we can do, and then go and try to do that. And if it cannot, then it will just say we cannot do that. So the idea is that you're creating a middle layer between a utility and the consumer, which is intelligent, and it tries to optimize everybody's requirements. Those devices today are available in versions of 110-volt versions. And again, when I say available, I mean this is strictly research. So you have to sign on a piece of paper, which David did, and so did I, that in case the car gets fried, that's just a little bit of risk. I'm kidding. Nothing has happened so far. Nothing has. I mean, if anecdotal evidence is useful, nothing has happened so far. I have empirical data. All the EVs are still running. But this is we're talking bleeding edge and leading edge. Anyway, so that device takes very fine measurements of information, sends it back to the control center. Control center can send information back. It can control. It can turn that EV off. It can turn the EV on. And the next release of the system in the next 1 month will actually control the exact amount of current that you can send back to an EV. And when you start aggregating all of these, that's when things start to get very interesting, exciting, challenging. And also consumers, that's when consumers start to weigh in. And so we're doing some interesting experiments in parking lots, in different parking lots, lot 9, lot 8, and other devices going up in lot 6. And my target is to go from 7 EVs to 100 EVs by the end of this year. So I found a BMW today. I don't know whose it is. You'll see my business card on it. Yesterday we had one of your colleagues, I guess, had parked, and so Fisker, I put my business card on it. If I see electric car, you expect to get my business card on it. But that's how we started, right? I mean, we just literally went around the parking lot. We found these professors and people who owned EVs and said, do you want to be part of our experiment? And 100% of the people said yes, and that's amazing. We have to do some testing in the lab. At the end of the day, ours is an information infrastructure. It has to tie in with the commercial systems. That's when it will start to become useful. So that is the next step for us. So we're looking at, for example, Clipper Creek is one of the systems we're looking at, and some of the other systems as well. I talked a little bit about solar. So we have another activity with solar to grid. The student is experimenting. We've created a little wireless device into which you can send signals, and you can take energy from the solar PVC to the battery, or battery back to the grid, or solar directly to the grid. So that's all part of our microgrid research. LA is a very important city, and I think Secretary Stephen Chu was here, and you see the person talking to him is Mike Swartz, and I'm with Mike Swartz. Mike, there's. And but this really shows you, and I'll tell you, the most important reason to have this picture, you see in the background, there's an EV, there's an electric car. And that electric car, there was a lot of electric cars that day. And there were electric vans, there were all sorts of vehicles that were parked. It shows you that right here in LA, we have a lot of companies that are already participating. We don't have to go anywhere. we don't have to worry about doing simulations like, if you're somewhere else where there were no EV. A lot of these researchers are in the country are simulating, what if we had 200 EVs? I say we have them in town. We just need to leave our business cards on every EV. We talk of regulation. We talk of pricing. It's very critical, and I rely on the decision makers to make the right decisions. The oil industry got lots of breaks when they started, and I think the EV industry needs that. I'm not a policy guy, but I can tell you that I think we have some breaks, and I think that needs to continue, and perhaps more breaks are needed if you want to get from where we were to a modern grid, right? And I think that while the grid is getting modernized, EVs are going online, there's wind and solar, there's a lot of changes. And so what happens is that there's innovation, then there are standards. So we innovate, we diverge, then with standards we converge. And just like, for example, in the plug that plugs, the device that plugs a car into a charging station, that's the J1772 standard. Because of that, we can now install these charging stations and everybody can charge. And so I think that when you look at the policymakers, they're very critical, and this is a policymaker from California Public Utilities Commission. The head of that, Mike Peavy, was here a couple of weeks ago, and he spoke at one of our events. It's very important to have, I think, participation from leaders like that. And my time's up. Thank you very much.